Hi, Noel chemists. Today we're going to choose our molecules that we want to adopt. And we're going to take a look at a project from last year by one of our seniors. So let's get started. First thing I want to show you is the list of adoptable molecules. This list is by no means exhaustive, meaning this isn't the only molecules or these aren't the only molecules that you can adopt, but this is a good place to start. They're organized in groups just to help you find something that interests you. First, molecules found in the body. Just going to hit on a few of them. Tryptophan, this is an amino acid. It's believed to be the amino acid found in turkey meat that makes you very tired after a big Thanksgiving meal. Adrenaline, we know what that is. It's released by our adrenal glands that sit up on top of our kidneys. And when you have that surge where you're going to see a cat get run over by a car and you run and scoop up the cat and run to the other side, and people say, how did you run that fast? And you say, I don't know, it was just adrenaline. You know what that is. It's just speed released in your body. Vitamin D3 makes you have strong bones, and it's made inside your body when sunlight hits your skin. Cholesterol. We all know this is the stuff that clogs up our arteries, but did you know that every cell in your body has a cell membrane made of cholesterol? If you don't have any cholesterol, you don't have any cells, and if you don't have any cells, you're not here. Melanin, this gives your skin its pigment, its color. Melatonin, this makes you fall asleep. Melatonin and my lectures, I'm sure. Testosterone, it's a male hormone, but females have some of it too. Estrogen, hemoglobin, this is the stuff inside your red blood cells that carries oxygen. Serotonin puts you in a good mood. How about molecules that are found in nature? Things like vitamin C or ascorbic acid. It's found in a lot of fruit. How about chlorophyll that gives leaves its green color and also allows them to perform photosynthesis? How about things like citric acid or carvone? This smells like mint and rye. How about certain chemicals that are found in medicines or drugs or food additives like aspartame or caffeine or aspirin or cocaine? This is a section that kids always love to gravitate to. Penicillin, Viagra, no judgment. Nicotine, morphine. There we go. Let's move along, shall we? Industrial chemicals. I told you that chemistry is life, and almost everything you do, you use chemicals. You use butane in a lighter. You use propane in the big tank to put on a grill. PVC, the PVC pipes, this is what they're made of. Polytetrafluoroethylene. Say that fast. How about this? This is what's in plastic water bottles. BPA. We don't want any of that. How about Teflon for your cooking? Okay. Oh, that's what Teflon is. Polyvinyl chloride is PVC. You got to watch me. Okay. Next, let's scroll down a little bit further. How about pollutants and toxins? These are things we use all the time. Freon, we use that inside the refrigerator. DEET, we use that in mosquito repellent. DDT, we use that in a pesticide for crops. Agent Orange, poisonous chemical we used in the Vietnam War. And this, methyl iodine. So last year, one of my students decided to look at methyl iodine, this toxic pollutant and chemical that we spray on strawberry fields to keep the bugs, particularly the fungus, off of strawberries. Now, if you want to have a good yield of strawberry crops, you can't let the fungus and the pesticides eat them. But it's also very dangerous when you spray something that is not only going to be toxic to the fruit, but toxic to the human. So, without further ado, I now want to take a look at this particular project. Okay? This project is about methyl iodine. What is it? It is mixed into water and then sprayed on strawberry fields in particular, sometimes kale and spinach, to keep away pesticides so the crop will have a good yield. It's very pungent in odor, meaning you can smell it. And it is a pesticide. Its chemical formula, and they will ask you on this presentation and sometimes in points in the checkpoint, what is the chemical formula? And kids will always say, what is the chemical formula? And here it is, CH3I. What does that mean? It means there is one carbon when there's nothing there, when it's nothing, no letter in a subscript, no number in a subscript. That means there's one. So there's one carbon. There's no need to write C1. We just write C. It's understood if we're writing it, there's at least one there, but there's only one. So here's our carbon. It's the very center atom. And here it is in the black. We have 3 hydrogens. Boom, boom, boom. 1, 2, 3. The hydrogens are these tiny white balls. And then above is the iodine. And it's as simple as that. Here's the chemical formula, CH3I. Here is the structure. Okay. So there's a lot on this slide, and perhaps there's too much writing on this slide, but the information on the slide is very good. And what it says is that there are some short-term side effects to spraying this. You're choking, you're wheezing, sometimes you get headaches, you faint, sometimes you get skin irritations, but over time, you develop cancer. And the problem with methyl iodine is that it doesn't just get into the air and the people who are spraying it or who live near farms inhale it. It's that it gets into the dirt, the soil, and then it begins to grow up into the fruit. And then you go to the market and buy the fruit, and you think if you run it under the faucet, you've cleaned it off, but you haven't, because the methyl iodine has grown up with the fruit, particularly strawberry, spinach, and kale. Okay. And several watch groups release something called the Dirty 30. And these are 30 foods in which growing them really requires a lot of pesticides. Well, let me not say requires. That's the way they're largely grown by the industrial agricultural complex, by large farmers. I grow tomatoes, and I don't use pesticides on them. I don't use any kind of toxic spray on them. But we go out every day and make sure that there's no fungus or bug or something on them. Okay. But in people who grow large industrial amounts of food and sell it to supermarkets, they use a lot of pesticides. And these particular 12 foods are very high in pesticides. Strawberries, number 1. Spinach, kale, nectarines, apples, grapes, peaches, cherries, pears, tomatoes, celery, and potatoes. And again, if this pesticide is sprayed and gets into the soil and then grows up with the fruit, can't wash it off. Here are some foods that tend to be cleaner. Oopsie, avocados, sweet corn, you could read the whole list. Why is this important? Because people who ate organic foods or foods that did not have pesticides had 25% less cancers in a journal of the American Medical Association of Internal Medicine in a study they did. 25% less cancers, including breast, prostate, colon, and skin. Then Alizé goes in to talk about something really interesting. How does this affect society? So it's not just knowing about this particular chemical, but I want you to tell me, how does it affect society? Well, there's a gap between the rich and the poor, a nutrition gap. We know there's an income gap, but that gap leads to a nutrition gap. If you have less money, then you can't buy organic fruits and vegetables. And if you have less money, you live in a neighborhood where such stores are not available. Whole Foods is usually in affluent or wealthy neighborhoods. You have to have a lot of money to buy organic foods. They tend to be more expensive and they last a shorter time because there's less chemicals and preservatives. And so the food is more expensive and it doesn't last as long, and it's often a long walk or to travel for poor people to get to it. And so what happens is that this inequity in wealth leads to an inequity in nutrition, which leads to an inequity in health. And we know that poor people have less access to health care, and the access they do have is to lower quality healthcare. So this thing just mushrooms over here. Now we see that methyl iodine is not only toxic to people, but it's toxic to the environment. What happens to methyl iodine when it breaks down is it becomes methane, a greenhouse gas, which surrounds the earth and traps the sun's radiation next to the earth and starts us on this toxic cycle of the earth gets hotter, the global temperatures rise, and then the ice at the polar caps melts, and then the whole sea level rises. And here we go, folks. This beautiful slide, which shows a lot of the effects of inequity on disadvantaged groups, how the greater exposure to climate hazards and the greater damage and the less ability to recover. And methyl iodide was banned in 2017, but as luck would have it, some farmers have stockpiles of it. And all they did was pluck off that iodine, put on a bromide, and they're in the same family. And away we have it. We're back in business. Now, this last slide, Alize hadn't finished at this point when she shared the slide deck with me. And what her big conclusion was going to be is that now that we know all of this, why did she learn this? Just to learn it, to pass this course? Yes. But she also learned it to say, how can I change this? This bothers me. How can I change this? What do I do? How do I become active? How do I change my personal behavior? And how do I change our collective behavior? And how do I message out about this to people who don't know it? She brought in, when she gave this talk, a bunch of fruit that was both organic and non-organic and had people test it, and then talked about the prices of the fruits and vegetables and asked people, what would you do? So very interesting. All right, so I'm going to stop sharing now. For this particular checkpoint, your main job is to choose what you would like to do, pick your molecule that you would like to do your project on. And if you don't see one in the list there, please feel free to pick one that interests you and talk to me first. And if you have not completed your atomic structure focus area, please go back up to activity 1 and look at both the video and the slide deck and text me when you're ready to take it. Now, after this video, you're ready for the checkpoint where we really begin to do some of the research on our chosen adopted molecule. See you next video.